Limit of function with two variables at the particular point a comma b. In this video, we are going to learn what are the limits of these three functions. In this case, you can observe that we have 1 by 0 form in each term. There is a specific reason to consider this example separately because we need to observe whether that is a 1 by 0 or a 1 by negative of a 0. Let's learn that concept, but before that we will learn what are the graphs of cot inverse and tan inverse. Here we have the graph of cot inverse x. As you can observe, this graph is bounded between 0 to pi. As x tends to infinity, this graph tends to 0, whereas as x tends to minus infinity on the negative side, this graph tends to pi. Limit x tends to infinity, cot inverse x is equal to 0, whereas limit x tends to minus infinity, cot inverse x approaches to pi. On the other hand, tan inverse graphs look like this. Again, this is a bounded function, but between minus pi by 2 to pi by 2. In this case, what is the limit of tan inverse x when x is approaches to infinity? When x is approaching to infinity, this function is approaching to pi by 2. And what is the limit of tan inverse x when x is approaching to minus infinity? In this case, when x is approaching to minus infinity, this function is approaching to minus pi by 2. Here we have the two basic results for the tan inverse as well as for the cot inverse. Also observe the graph of e raised to power x as well as e raised to power minus x. In this case, as x tends to infinity, this graph tends to infinity, whereas as x tends to infinity, in this case, this graph approaches to 0. So we have two results, that is limit as x tends to infinity, e raised to power x is approaches to infinity, whereas for e raised to power minus x, as x tends to infinity, this function is approaching to 0. Now we are in an actual position to find the limit of this function, that is tan inverse x by y whenever xy approaches to the point 1, 0. If we substitute directly, we are getting a tan inverse 1 by 0. However, we should not say that this limit is equal to pi by 2. To understand why, let's first examine a one variable function. Suppose we have the function as tan inverse 1 by x as x approaches to 0. In one variable function, we need to check both left side limit and right side limit. For the left hand limit, as x approaches to 0 from the negative side, we are getting limit h approaches to 0 tan inverse 1 by 0, that point, minus h. And in right side, we are getting limit h approaches to 0 tan inverse 1 by 0 plus h. How we are writing this? When we need a limit as x approaches to a of a function from the left side, we are writing this is a function a minus h. In case of from right side, we are writing a plus h. Same procedure we have followed in this case. As x approaches to 0 from the negative side, we are writing this one. As x approaches to 0 from the positive side, we are getting this form. In this case, when you put h is equal to 0, we are getting tan inverse 1 by minus 0, that is equal to tan inverse minus infinity, that is equal to minus pi by 2. It means this function is approaching to minus pi by 2 as x approaches to 0 from the negative side. Whereas in this case, when you put h is equal to 0, we have tan inverse 1 by 0, that is equal to tan inverse infinity. This function is approaching to pi by 2. In right hand side limit, we are getting a pi by 2 as x approaches to 0 from the positive side. Limits are not equal. Therefore, we conclude that limit does not exist in a one-dimensional variable. The same behavior occurs in a two-variable function. This expression can be rephrased in this form. Rather than x is approaching to 0, y is approaching to 0, either from the top or from the bottom. Whereas x is approaching from any of the path, that x is always positive as it is on the right side of the origin. In this case, we can take always positive 1, but we need to sure whether this y, when we substitute 0, whether this is a negative, positive, or can be the combination of a both when we are taking from any of the path. In case we are taking any path that is approaching from the above x-axis, in that case this y is positive and we are working with this procedure. And if we are taking any path that is coming from the bottom of the x-axis, in that case y acts as a negative, or we can say that we are working with this rule. In short, in this case, limit of this function does not exist. Always remember, whenever we have 1 by 0 that is equal to infinity, you just need to figure out whether this 0 is always positive from all the paths or always negative from all the paths, or can be negative or positive depending upon the path. In that case, limit can vary. Here we have the graph of tan inverse x. In this case, this represents the y is equal to 0 and this represents the line of x is equal to 1. On the left side of a 0, we are getting a negative value. Just on the right hand side, we are getting a positive value of the function. This graph is look like this way. In this case, we have taken this is as the x is equal to 1 line and here it is a line of y is equal to 0. On the left side of the 0, this function is approaching to this point, that is near to the 1.5 with a negative sign. Whereas on the right hand side, the function is approaching to the positive sign of a 1.5. There is a jump discontinuity in this case. It means limit does not exist. Next example is, in this case, we need to find the limit of this function around the origin. When you direct substitute x is equal to 0, y is equal to 0, now again we are getting a 1 by 0. We need to show if coming at origin through any of the path, maybe on the positive of y-axis, maybe through the negative of y-axis, maybe through the positive of x-axis, or maybe from the negative of x-axis. When you substitute the values in this case, whether that quantity is always positive, or we can say that we can take any path to approach at origin. Maybe in that case x is getting a positive, maybe y is getting a positive, maybe both are negative, or maybe having an alternative sign. This term is always positive because we are taking the square of these individual terms. In that case, we will always get a positive of 0, and this is equal to cot inverse infinity, and cot inverse infinity is 0, means as this internal term is tending towards the infinity, the cot inverse function is approaching to 0. For this case, we can say that limit exists and the value of limit is 0. Here we have considered the function graph. So as you can observe, x tends to 0 and y tends to 0. This function is getting 0 from all the directions. So if you choose any of the path, any of the direction, at x is equal to 0, that function is approaching to 0. Next example is, we need to find the function value whenever this is approaching to origin. So around origin, what is the value of this function? So what we can do, we can substitute x is equal to 0 and y is equal to 0. When you substitute that, we have exponential 1 by 0 form. Now whenever we have 1 by 0 form, again we need to predict whether this is a positive 0 always or a negative 0 or combination of both. Basically in this case we are going to approach at origin from the many ways. Either you can come from this way or this way or this or this and so on. So it's very difficult to identify for each and every path. What we can do, we just need to check first from the positive axis of y. Take y as a positive 0. 0 positive plus 1, this is a 1. And when coming from the bottom, that is a 0 negative plus 1 form, again it is a 1. This indicates the numerator term is always 1. We just need to figure out for x approaches to 0. So in this case, we can say that we can reduce this limiting form as x approaches to 0 exponential 1 by x. So we can find its left side limit as well as the right side limit. We have this x-axis at 0 when we are approaching from the left side. The left side limit as this. Now substitute h is equal to 0. So we have exponential of 1 by minus 0 exponential with negative of infinity. We have already learned in the starting of this video, this function is approaching to 0, whereas for the right side limit, we can write this. From here we have always a positive of x. We can write exponential of 1 by 0, that is exponential at infinity. This value is approaches to infinity. So in this case, we are getting an infinite value when we are approaching to the 0 from the right side. We are getting a two different values in this case, and hence we can say that limit does not exist. Although it's a very difficult to identify with a particular procedure for the two variable whether the limit exists at that point or not. Specifically, whenever we have a 1 by 0 form or 0 by 0 form or any other undetermined form, we can use a different procedure in order to find that limit does not exist.